Okay, so yeah. Everyone can see me and hear me. If there's any issues, let me know. I'll type that in the chat as well. Right, so thanks for waiting a bit, and yeah, do invite your friends to join in. We are going to be here for about 2.5 hours, so you have already had a very stressful 2.5 hours. I think hopefully this will be a relaxing 2.5 hours. Relatively relaxing compared to the 2.5 hours you had this morning. Okay, so yeah, all of you have been in the last couple of years' videos, you have also probably seen it, so routine will be roughly the same. Alright, so yeah, let me know if in between my connection cuts or if I say something wrong. No, that's very possible because I basically just got a copy of the questions about 2.5 hours ago, and so I basically had just as much as time as you had to prep all of these slides and the questions, as well as to do the problems once through. So if anything is weird, just let me know, right? So I usually say trying to discuss the cutoffs too much. That's mainly just because I don't want you to get too frightened or too depressed or too disappointed, and also because we really don't know, right? For example, I think some of you know this if you are in Sec 2 this year. Last year there was a huge drop off in the number of round 2 spots for junior, right? It was I think about 110 instead of 190. So really, we have no idea what is the Singapore Math Society going to do in terms of number of places, right? So I have no idea how cutoffs are going to be. I have no idea exactly how things are going to be scored. And so if you want to speculate, feel free, but we really don't know because more or less qualifiers can be chosen. They can make it more stringent to get a gold, or less stringent, it can be more or less stringent to get a silver, and so on. Okay, now do let me know if you see anything that I'm saying which is wrong. That may happen, and it is a discussion after all, right? It's not just entirely meant to be me talking non-stop. So same thing, I'm not going to go through the computational steps in great detail. So things like expansion, multiplication and division, prime factorization, I will just state it. And obviously, if you were doing it in competition, maybe that step would take 1 minute. But I just want to fast forward that so that this session is as efficient as possible. And at least half of you may end up watching this back again on like the 28th of May 2024, right? So we don't want this to be too long-winded. Yeah, so one suggestion which I think I should make, I haven't made this last time, is that you should already start looking at some round 2 problems regardless. Because for the round 2 questions, it takes a while to get used to it. So if let's say that you think you're borderline, you say that, okay, I'm scoring like 14, I'm scoring 13, or like, I'm not sure if that's enough. I'm also not sure if that's enough, but you can look at the questions for some of the round 2 problems just to get a sense of what you are going to be up against if you do qualify, or if you are a Sec 1 student, then next year's SMO. And if let's say you are doing the SMO senior next year, then the SMO junior round 2 is going to be much easier than the senior round 2. So at the very least, you should try to get comfortable with it, even if you just missed by 1 point. Okay, comfortable not to mean that it's easy, but just generally comfortable. Yeah, and this is a fairly weird paper. I have a few things that I think I can say which about how this paper is weird, but don't really need to say that, right? You guys find it weird enough too. Okay, so without further ado, I think we have got a lot of people in 140. Wow, that's a lot of people. So yeah, still invite your friends in, celebrate together, mourn together, and let's get straight into the problems. Now, the first thing that I want to say, especially because of some of you who will be watching this back again, or you are P6 watching this, the questions are not at all in order of difficulty. They tend to get more difficult, but it's sort of like climbing a mountain. I'm not sure if any of you realize that climbing a mountain doesn't just involve going up. A lot of the times you go up, then you go down a bit, then you go horizontal, you go up. So you generally go up, but you don't continuously go up. And that applies even for some of the last few questions that are not very difficult. Okay, so question 1, that's it. Indeed, it's not very difficult. But if you were to look at, let's say, some of the last 5 questions, they are also not very difficult. Okay, let's get started immediately. So question 1 is very easily a primary school PSLE kind of question. So the usual way to do this is just draw a table. And so I shall just draw the table of men and women, and then those with a degree and those with no degree. You can choose to name your variables as your preference. For me, I'm going to just use the half of the degree holders are men. So the degree holders, I would just put it as X and X. And 40% of the non-degree holders are women. So 60% are men and 40% are women. So it would be 3:2. So I'll just call it 3Y and 2Y. So now we're told that 1/3 of the employees have a university degree. So that means that this is 2x, this is 5y, and 5y should be twice of 2x. Okay, so y is 4/5 x. And then the numerical information is that 102 of the employees are men. Okay, so x is 30, y is 24, and then 30 and 48 sums up to 78. So congratulations, you have got 1 mark. Second question. Now, a general rule of thumb is that even without seeing the question, if the question just says how many, and the options are very small, you can list. There is no good reason why you cannot list when the worst possible scenario is that there are 5 of them. So just list, and non-congruent just means don't repeat the same combination of sides. Perimeter 7 means that there are not that many combinations since these are integer. Now, the one thing that you need to know is your triangle inequality. Basically, it tells you that the longer side cannot exceed the total of the 2 shorter sides. So for example, something like 4, 2, 1 is not going to work because you're not going to be able to close this triangle. Yeah, in fact, this tells you that the longer side has to be at most 3. And immediately this tells you that we only have 3, 3, 1 or 3, 2, 2 as the 2 possible combinations. That's it. So if the question you might have is how do we do this if the numbers are bigger, then you will still list, but you would probably list it as, okay, if the bigger side is 10, how many possibilities, 9, how many possibilities, 8, how many possibilities, and total them up. But here just a direct listing is fine. And this is going to be a theme that is repeated for a lot of the junior questions. If listing works, don't look for something more clever. There may be something more clever, there may not be, but you don't need to look for it. If listing works, just list. So question 3 is an example of listing works. But you need to make sure that your list is complete. And when we list, you want to make sure that you are listing out a limited number of possibilities. And so the median is a convenient thing to list because the median is the middle number when you arrange them in order. And so the middle number only has a few candidates. Now 4, 7, 10 and 11 are in order, but n is, we're not sure. So n could be in this position, meaning 10 is the median. If n is somewhere on the left side, then it's possible that 7 is the median. And if n is in the middle, then n itself could be the median. Now, there's no way that 4 or 11 can be in the middle, but 7, 10, and n can all be in the middle. As long as the list is not exhaustive, then we may be in trouble. But if the list is exhaustive, then don't look for something better. Okay, so if each of these candidates tells you that you are targeting a sum of 50, 35, and 5n respectively, the first four numbers add up to 32. So you get 18, 3, and then this is n equals to 8. So just to check, if 18 is the value of n, then 10 is really in the middle. If 3 is the value of n, then 7 is really in the middle. And if n is 8, then n itself would be in the middle. So all of these three we can accept. And so the answer for the total is 29. Question 4. Now, from the outset, I want to just say something about the SMO junior geometry questions. I'm not going to write it down, but I'm just going to say it verbally. You more or less only have 3 or 4 ideas. 1 would be Pythagoras theorem. 2 would be similar and congruent triangles. 3 would be ratios of areas. And 4 would be some basic angle properties. That's about all that there is really. Because everything more complicated than that, whether it be cyclic quadrilaterals or whether it be trigonometry or triangle centers, all of those are not going to show up until at least the SMO senior. So you can almost go by a process of elimination if you are a little bit stuck as to what can work. Obviously, in this figure here, there are no similar triangles because there are no triangles. At least, not yet. The other thing that you want to ask yourself for any of these geometry questions is that what makes this figure this figure? If you don't use all the information, then it's going to be like as if you have just a floating semicircle or you have just got a floating line. So AB is 16. AB is on the big semicircle. C is on the small semicircle. And it is tangent, touching. So in order to use that, I can just draw the right angle first. What else? Parallel to the diameter DE. Now, parallel to the diameter DE means that if I were to draw in this perpendicular line, it is going to indeed be also perpendicular on the other side. So this is just a rectangle. It also means that if AB is 16, then by symmetry, both halves are going to be 8 and 8. Okay, so now let's remind ourselves of the question. To find the area of the shaded region, what you want is pi times the big radius squared minus pi times the little radius squared. And they're semicircles, so 1/2. The little radius is here, and the big radius is here. So great, right? This literally just gives you a triangle that you can Pythagoras immediately. Okay, and from there we are done. Finally, question 5. Yeah, this is one of the things that I would say makes this paper a bit strange. It's been a while where you didn't really get any like graph questions where they actually show you the graph. There have been 1 or 2 questions where you are supposed to use, let's say, a straight line graph or a quadratic graph, but it's pretty rare to have something like this. Now, this is actually a problem from like a 30-year-old SMO open round. If you are curious, this is almost exactly, I think from 1995 or somewhere thereabouts. Very old. Now, I noticed some of you were talking about some ambiguities about this question, right? It's true that you can't find A, B, and C for sure just based on what's given inside the diagram. But you can still get some information based on what is provided. So most of you haven't really learned graph sketching. But when you talk about the sketch of a graph, the important points and the general shape are the only things that actually matter. This is not plotting a graph. Plotting a graph is what you would do in your science lab, in your physics practical, where you cross out all these and then you draw a line that is supposed to fill up 2/3 of your graph paper. That's not sketching a graph. So here, the important feature, one is that I can see where it is at -1. At x equals to -1, y is positive. And at x equals to -1, a minus b plus c is going to be y. So that confirms option 1 to be always true. I mean, definitely true based on this diagram. Now, for the other thing, you see that these are talking about the signs of A, B, and C. Now, the fact that it's pointing downwards, the shape tells you that A is negative. Right? A is negative, meaning that if x is very big, then it becomes negative a very big number. If x is very small, ax squared is also negative a very big number. So the shape tells you A is less than 0. Now, for the other two things, B and C, there are a couple of ways that you can figure out whether they're positive or negative. So I'll tell you both so that you know that there are actually multiple options for this. Now, the first option is to use Vietas. Right? Someone suggested in the chat Vietas, and that's correct. So Vietas tells you that the sum of roots, and the roots are here, both roots are negative. And so therefore, the minus b over a, which is the sum of roots, is negative, and c over a, which is the product of roots, would be positive. Now, since a is negative, this tells you that b is negative and c is also negative. So this is one way that you would be able to deduce this, that option 4 is correct, and of course option 3 and 4 are opposites to each other. The second way that you can do it is just from the graph, which is that the y-intercept when x is 0, this is the point 0, c. And so that means that c is less than 0. And to get minus 1 as the maximum point means that if you complete the square, minus 1 would be that vertex. So if you factorize out a, so I'm just doing the usual completing the square here. Now, I just dot a dot because the important thing is that the minus b over 2a is minus 1. So b is going to be equal to 2a, which is negative. So this is the other way in which you can conclude this. One way or another, you are going to get option A as the correct answer. Yeah, so you're right that you can ask what does not drawn to scale mean, but I guess even though I understand the issue is that not drawn to scale doesn't mean that, for example, a positive number can be taken as negative, a negative number can be taken as positive, right? So some reasonable assumptions can be made when you're talking about not drawn to scale, right? So this is usually what it entails. Not drawn to scale means that you shouldn't try to measure it and say that, okay, if this is 1 in distance, then this is going to be somewhere like 0.6. That's what we mean by it's not drawn to scale. You cannot go and measure that, right? But it's not to say that you cannot use any features of the diagram. Otherwise, the graph is useless if you cannot use any features of the diagram. Okay, so that's our multiple choice section. As we're moving on, I just want to say a word about the usual difficulty patterns, right? Now, the usual difficulty patterns are that within the first 5 multiple choice, you should expect about 3 of them to be on the easier side. And then you expect that usually question 5 is more difficult. And then after that, question 6, it just drops back off again. So very often, question 6 is one of the easiest questions in the whole paper. So the multiple choice section is kind of like a mini 5-question warm-up SMO in a way, and then question 6 sort of resets to be the main 20-question SMO. So there is very little correlation between the difficulty of the first 5 and the other 20. Okay, so question 6. The product of the ages of 3 adults is 26390. Find the sum of their ages. The question is kind of nice because they say find the sum and didn't say something like find all possible sums. So you know that if you are told that it's all possible sums, you might have to consider the possibility that there are multiple, but here you do not need to consider that possibility. What we need to do here is mainly to just prime factorize. Now, usually when I prime factorize, I just take all the obvious factors. And so 2639, the obvious factor is 13 because 26 is 2 times 13 and 39 is 3 times 13. Now, in case you accidentally thought 203 is prime, then obviously this will be impossible because you can further split it up into 7 times 29. So now you just have to play a little bit of jigsaw games because you have got 5 of these prime numbers and you need to group them together so that you get 3 adult ages. This is quite easy to do just by guess and check. The logical way to say it would be that if there are 5, then one of them will need to be alone. So 29 needs to be alone because that's the only one above 21. And then 2 can only be multiplied to more than 21 if you group it with 13. So the only combination that will work is 26, 35, and 29. Question 7. Yeah, funny enough, we can say that question 7 is probably the first one that is a question which you have seen maybe 5 different versions of it if you look through the past SMO papers. There's always one of these, something is a factor of something else. If you haven't seen this before, then you may be thinking, hey wait, that seems to be wrong, right? Because n plus 11 is actually a factor of n squared minus 11 squared, which is n squared minus 1 to 1. Right? So if you were to see this, then maybe you thought that, hey, the question is wrong. But that's not really a good thing. If I told you something that is always true for any value of n, then the answer would be infinity, right? The largest possible value quite literally doesn't exist. So in fact, it always must be an expression which is not actually algebraically a multiple of the factor. So n squared plus 1 to 1 basically is going to be n squared minus 1 to 1 plus the extra factor. Sorry. And so therefore, if you want this to be a multiple of n plus 11, it means that this must be a multiple of n plus 11. Now, of course, I have just written this down, and I wrote it down because it was part of my explanation when I talked about plus and minus. If you are used to doing long division, then long division is probably going to be the more brainless way to do it that is going to be also correct. So if you do it by long division, the quotient will first be n, and then minus 11. So minus 11 and minus 1 to 1, and so the remainder will be 242. That's basically what I've written down on the left side. All of this is just telling you that n plus 11, to make n as big as possible, should be just equal to 242 itself. Okay, when are we taking our break? I think we'll go on to question 10, then we'll take our first break. Now, question 8. Find the largest integer less than or equal to 3 plus square root 5 cubed. Now, there are a couple of ways that you can do this. The first way is to just cube it. That, of course, requires you to be comfortable with your cube identity. Three cubed plus 3 times 3 squared times square root 5 plus 3 times 3 times square root 5 squared plus square root 5 cubed. Okay, so this will be 72 plus 32 square root 5. From here, what you can do is to just try to estimate this. In trying to estimate this, one way is obviously if you happen to know that square root 5 is 2.230, then good for you. But in the more likely events that you do not know square root 5 to a bunch of decimal places, the easier way is to bring in the 32 inside the square root. And the reason why this is a good idea is that you only need to estimate this now to the nearest integer, i.e. find the nearby square numbers. So the nearby square numbers, 70 squared is 4900, 71 squared is 5041, 72 squared is 5184, and so therefore this is going to be 71 point something. And so this is one way to get the answer of 143. Now, there is also another way to do this if we make use of the fact that 3 and square root 5 are very close together. The way that we can make use of that is to bring in the conjugate and cube it as well. And what will happen is that you are just going to have the plus become minus in alternating positions. And so if you were to take both of these and add them together, you realize that the square root portion is going to cancel out. So the two parts that you're left with, both of these are your nice values. 27 and 45 times 2 this is 144, and 3 minus root 5 cubed is just less than 1. So 0 point something, and therefore it means that this is 143 point something as well. Okay, so there's an alternate way that you can do some of these. It may not really be needed for this question because 3 plus root 5 cubed is not so bad. But if let's say you have something like a fifth power or something more messy, or you have something like, I don't know, 11 plus square root 117 or something ugly, then this is worth considering. Question 9. Question 9 is one of the questions which I solved in the MRT on the way here because I looked at it and I just thought to myself, there can't really be that many possibilities when you have told me that this is in the 300s range. Now, what I'm trying to say is that 300 and something times what is going to give you in the 7,000s, it's quite clear it's going to be 20 something. So that should suggest x is 2. To be more precise, if x is 1, the product is going to be less than 14 times 400, which is going to be too little. If x is at least 3, the product is going to at least be 34 times 300, which is too big. So straight away, x is 2. And then you just divide 7656 by 24. So this kind of arithmetics, right? There are two ways it can go. It can either be very fast or very slow. This one, because of how many things are given, right? You're given the final product, and you're given a first digit and a last digit. I could have looked for the last digit. I could have tried to prime factorize 7656. My choice was because I noticed that x is going to more or less control the size of the product. So that's why we started with that. Okay, question 10. This is the bread and butter of the SMO algebraic manipulation kind of questions. As a matter of fact, just this morning I was teaching some of a class of primary 6 students, and like as a sort of introduction to the SMO style question, this is sort of the introduction to the SMO style question, where you don't find x and y, you just use building blocks to, well, build. So how you want to build is that you just want to find like a few stepping stones. And your stepping stone is going to be just via x squared plus y squared. That's usually how this goes. Okay, so that's your path, and x squared plus y squared would come from x plus y whole thing squared minus 2xy. This is 124. And then you square it again. Yeah, so the SMO, every now and then you need to do this kind of computations, right? So take your time to do it correctly, because we're not used to doing this without a calculator most of the time. So if we're not used to doing this without a calculator, there is a very high tendency that we mess up. There we go. So that's up to question 10. Yeah, so we will take now a quick 5-minute break. If you want to continue to discuss in the chat, feel free, of course, and we will be back very shortly. Before we continue, just wanted to quickly make a suggestion, because quite a number of you guys who are watching this are all Sec 2s, right? So that means that unfortunately you will have to take senior from next year onwards. So do consider just taking a peek tomorrow in the senior session as well. The gap from junior to senior, aesthetically speaking, is quite big. Meaning that for junior, you have got maybe 5 or 6 questions at least that are just primary school style questions. You don't quite have that luxury for the senior. And also, there will be some questions with like very messy looking stuff that you might not even be able to start approaching yet. So it's just good to have a sense of what's coming up for you guys in 1 year's time. Although, obviously, you don't have to panic just yet. Just good to see what's coming. Okay, so let's continue on with question 11. Now, for question 11, the first important thing is that it mentions positive integers. So if it mentions positive integers, then again, technically, you can list. But we're not going to just list blindly. We want to at least have some sense of where we're going. Now, I'm going to explain the same thing in just 3 different ways, which is going to come down to the fact that a squared plus 4b squared is greater than or equals to 4ab. Right? This is true by either AMGM or just a minus 2b squared is greater than or equal to 0. And both of these, the AB, the equality holds when the A and 2B are the same. Now that can't actually happen, but it just gives you a guide for where to look. Now if you are not familiar with AMGM, then for now another way that you can reason that out is that the largest possible product of AB would happen when you have the largest possible A squared B squared as well. And that also is going to be the same as if you have a maximum value of A squared times 4B squared. In other words, these two have a limited sum, and so to have a limited sum, whether you use AMGM, you use completing the square, or you use this argument, the conclusion is that A squared and 4B squared are both going to roughly be half of 1105. So the maximum will happen somewhere around there. A squared is around 552.5, means that A is going to be 23 or 24. And then 4B squared is going to be 11 or 12. So those are just the values that you need to try. Right, so if you try out values that are surrounding the theoretical optimum if we were using real numbers, if you put A equals to 24, then you basically get B squared is equal to 132.25, and so B is at most going to be 11. So this would give you 24 times 11 is 264. If you use the other side, A is 23. Actually, I mean, if you subtract 5 to 9, you recognize that these are the same two values, right? Except that this one, it can actually be equal. So that's a good sign. So b squared is less than or equal to 144, and so b is at most 12, and 23 times 12 is 276. So among these two, obviously this is going to be larger. Yeah, so you want the largest possible value of AB, not a smallest possible value, right? So largest possible value is going to be making them close together. Smallest possible value, then you drag them as far apart as you can. Question 12 looks something like what the last year's 21 or 22 or 23. There was a question with a glut of square roots last year as well, right? It just requires you to be careful when you do your calculations. So multiply over the denominator and then just grit your teeth a little bit and expand this all out. Now, if let's say you are the kind of person who has a bit of a phobia of surds or square roots, you can consider just replacing them temporarily by x, y, and z if you want. I'm not going to do that, but you can consider doing this before you expand, because sometimes x, y, z are easy to work with than like square root 3 times square root 6, then square root 5 times square root 10, right? Then you may mess things up. So if that happens to you a lot, then do consider just writing it in terms of x, y, and z. Okay, so I'm just going to expand in the most boring way, which is multiply the first two together. There's no identity here that is obvious to me, so I have no choice. Just 5 times 3, 5 times 2, 3 times 3, so that's just 3, and then square root 6, and then we just go again. Now, as a bit of a checking device, you realize that there should only be square roots left over. There shouldn't be any whole number part left over. So if let's say you suddenly have blah 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 plus 7, then you know you messed up. So that's like a checking mechanism you have. In fact, square root 5 and 2 root 2 also are a checking mechanism. If you got all of those right, it is very unlikely that you would have the coefficient of square root 3 to be wrong. Okay, so just expand it one by one. Square root 15 times square root 5, square root 15 times square root 2, square root 10 times square root 5, 10 and 2, 3 root 5, 3 root 2, minus 30 minus root 12. And then the rest of these we just need to simplify the square roots. You could have done it on the spot if you wanted to. And of course the square root 30 will cancel out, so we don't need that. So you can see that we have not messed up, because this gives you square root 5. This gives you minus 2 square root 2. And so therefore, if I take these two, n should be equal to 3. Yeah, it's not difficult to get right, mainly because of how many things there are to help you notice that you have gone wrong. So if you expanded, it is very unlikely that you would exactly get square root 5 correct, minus 2 square root 2 correct, but then your coefficient of square root 3 just happens to be wrong. Right? It's not very likely. Right? And that's the reason why this is not terrible. Now we get to the next reason why we say that this is a very weird junior paper, which is that logarithm question seems to have accidentally swum in. Now for a bit of context, right, When I was taking the SMO Junior, I took the SMO Junior in 2008, 2009, and 2010. Those were the years where weird stuff does happen in the SMO. You do get expected to know very strange things. Sometimes the solution book doesn't admit it, right? They say that notice this, and then actually notice it is by Cauchy-Schwarz or by trigonometry, but they just didn't quite acknowledge it. They just said notice this. But this is still pretty egregious, right? So I'm just going to say a word for what these logarithms actually mean, which personally I feel that should have been supplied, right? This is not the most quote-unquote fair question. If you don't know what a logarithm means, can't solve it. Now, a logarithm base 10 of 12 just means that if I call these values, this value x, it just means that x is the solution to 10 to the x equals to 12. If I call this one y, it just means that this is the solution to 10 to the power of y is 75. So for instance, if I took log base 10 of 100, then that would be 2, because 10 squared equals to 100. It's basically the inverse of 10 to the power of something, right? So the opposite of squaring is square root. The opposite of 10 to the power of something is log base 10. The opposite of 2 to the power of something is log base 2. That's my few second crash course on logarithms. The pity is that if they had actually bothered to tell you this, then some of you could have solved the question even if you had not learned logarithms before. Okay, so that's a bit unfortunate. So I'm going to explain this without invoking any logarithms, okay? So, first of all, we are back to a number of possible values of n, where these are lengths of the sides of the triangle. So we're back to the triangle inequality again. This time, I'm going to write it a little bit more carefully. Just now, I just explained it because it was just listing, so I didn't need to write down any equation. The triangle inequality, if I call this thing z, tells you that z is less than x plus y. If z is the longest side. It's also possible that y is the longest side, and if y is the longest side, y also needs to be less than x plus z, i.e. z is going to be more than y minus x. So that means that your z, which is this entire log base 10 of n, is squeezed between x plus y and y minus x. Oh yeah, I should also write down that if I call this z, that also means that 10 to the power of z is equal to n. So, if we have y minus x and x plus y are the boundary values for z, then I can take 10 to the power of everything. And using your rules of exponents, indices, you can actually solve this question. This is just 75 over 12 is less than n is less than 75 times 12. So n will range from 7 all the way to 899. So my condolences for those of you who got a little bit shocked by this. One of the things I do want to comment is that the SMO doesn't actually promise that everything is going to be from Sec 1 and 2 syllabus. It's just sort of an unwritten rule that they try not to do something that is, let's say, in Sec 3 or Sec 4 topics. But something like, let's say, the quadratic formula or Vieta's formulas are definitely not in most Sec 1 and Sec 2 syllabus as well. So it's just that out of habit, we have never seen logarithms asked in the SMO Junior, so we assume that it's not tested. But basically, just try to learn as much math as you can when you're doing some things that are too specific to SMO Junior. If a different type of question comes out, we get stumped again. So it's a bit unfortunate, but it's also a useful learning point. Okay. Now we suddenly go back to a more normal question. But maybe if you get too shocked by the previous question, then your brain just registers that, oh, what is this? Yeah, someone mentioned calculus, right? Yeah, open, suddenly calculus shows up. It's a recent thing. Calculus is normally not needed in any Olympiads, even up to the IMO. It can be useful, but it's not really needed. But for most of these kinds of expressions, calculus is usually the way to go unless it's very special. This, thankfully, is very special because 2x squared, 20x squared. You've got x and 10x. So this is very, very close to being 10 times of the bottom, except that instead of 10, you only have 3. So you're short at the top by 7. Now, once you have done that, then this looks like one of the questions from the 2015 or 2016 Junior Round 1 MCQs, right? It's a very standard question where to minimize this whole thing, it means that you want to subtract as much as possible. And to subtract as much as possible, you want to divide by as little as possible. And to divide by as little as possible, it means you want to make the quadratic as small as possible. To make the quadratic as small as possible, you complete the square. So, complete the square. And it tells you that the minimum value of this is 7/8. So therefore your answer is 10 minus 7 over 7/8, which is 2. Now in retrospect, you might say, hey, I could have guessed that. I should have just put like x is equal to 0, then x is equal to like 0.5, x equals to minus 0.5. Well, that is true, that if you know the answer is integer, and if at x equals to 0 it is 3, then your options are either going to just be 0, 1, 2 or 3, and obviously this thing is not going to be 0. But anyway, this is the actual proper solution. Yeah, so about completing the square, for both the top and the bottom, it is not inherently wrong, but it doesn't always work. The reason why it doesn't always work is that if you had a choice, you would like to make the top small and the bottom big. But now they both end up becoming small at the same time, if you complete the square for both. So do we want them to both be small or both be big? Because they become big at the same time and small at the same time. So if you complete the square for both, you wouldn't really be able to tell what's a good choice. If you do this, then it is the most clear cut that this is a good choice. Okay, question 15. Continuing on our discussion of the possibilities for geometry questions, right? I said that ratio of areas, Pythagoras theorem, similar and congruent triangles, and basic angle properties. That's more or less what that is. When you see a lot of right angles, then one of the considerations will already be Pythagoras for sure. But also another consideration would be your similar and congruent triangles, because when you have similar triangles in configurations such as this, it means that you have got 3 similar right-angled triangles and all of their respective length ratios are going to be the same. And so with many right angles, there is a chance of that. Moreover, with a lot of equal lengths, it is a square after all, you may even get congruent triangles. So that's what comes to mind when I see something like this. Okay, now let me just write in the given lengths. The square has side length 16, so if this is 4, this is 12. Mx is 11, of course the whole thing is 16. And the one we want to find is Bn. So most of that side BC. Now if you have any trouble with recognizing these sorts of similar and congruent triangles, one way to think about it is that you just mark out complementary angles, right? So this angle here, this is a complementary angle. This is also its complementary angle. This is also its complementary angle. Right? All 3 of these are complementary angles to angle CBE. In other words, practically all the right-angled triangles you can think of are similar. So I'm just going to say quote-unquote all, right? Because most of them are useless. But all right triangles are similar. And when they are all similar, you just need one reference point, which the reference I can use is BCE. Because that is 12:16. So at least that's 3:4. So we know that this is going to be our good old-fashioned 3-4-5 triangle. Now, in fact, even though they are all similar, we suspect that there can be some congruent triangles as well because of the square. So I have to use this 11 somehow, and my gut feel is that this has something to do with using Mn. And so I can actually draw in a congruent triangle over here. And I hope you can see why this triangle that I just drew is congruent to the triangle BCE. Because we actually have got yet another angle that is complementary to CBE. So if I call this point here P, so PMN is congruent to CEB. So of course that means that I can borrow all the lengths from earlier, but to use 11, the most pertinent one would be AN is also equal to BE equals to 20, and so NX is equal to 9. So I can write in one more new length. And finally, since I want to find Bn, the triangle that I can use to find Bn will be this one. Right? BXN is one of my all right-angled triangles that are similar. They all contain those angles. So it's also 3-4-5. So Bn is 5/3 of Nx. And so it is equal to 15. And you can fill in all the rest of the lengths if you felt like it. Now, question 16. I think a few of you may have a weird deja vu feeling when you saw this question, right? And the weird deja vu feeling is because of last year's junior round 2 containing a very similar sounding question. This is not exactly the same. Now, this is not exactly the same for a couple of reasons, right? One is that the condition is A less than B. For last year's junior round 2 question, A could be equal to B. The second thing is that for last year's question, you get to choose the size of the set. Whereas here, the set is fixed as 1 to 2023, and then you are talking about its subsets. So it's not exactly the same. Now, this is basically just a worst case scenario question, right? So the question says, find the smallest positive integer k such that every subset with k integers contains 3 numbers like this. Meaning that you're trying to say that if I pick k numbers, one of them is the product of 2 others. And so if you want the smallest k, then this will be one more than the maximum size subset without any such ABC. Right? So effectively the question is asking you, make the biggest subset you can. So pick as many numbers as you can without this happening. And so in order to pick as many numbers as possible, you will do some sort of like a greedy algorithm in a sense. But your greedy algorithm needs to be wisely configured. You want to pick as many as you can in a way that will allow you to continue picking as many as you can. So let's say I want to pick as many numbers as I can. The first number that I definitely want to pick is 1. Why? Because 1 is never going to cause me any trouble, right? I mean, 1 times B is C will not happen. So 1 is fine. Now, do I want to pick 2? Not really, right? I don't really want to pick 2. Because if I pick 2, that means that now every time when I've got, let's say 3 and 6, I can only pick one of them. 4 and 8, I can only pick one of them. 5 and 10, I can only pick one of them. So it's not a very good idea. So I don't really want to pick the small numbers because they will give me many pairs of which I will have to throw away one of them. That's not good. And so if I don't want to do that, I would say that I want to pick big numbers instead. So I'm going to go from the other end, 2023 and down. Now, if you just keep picking big numbers, you are not really going to have a problem, right? Because let's say 2021 times 2022 is humongous. You're not going to get 2023. Even if you go all the way down to, let's say, 100 times 101, that's still too big. And so you can go on for quite a while because 45 squared is 2025. You can go all the way down to 45 without any trouble. Because any product here is going to be at least 45 times 46, which is going to not be of concern. So at this point, out of 2023, I have lost 43 numbers because I picked 1, but I lost 2 to 44. So this current size is 2023 minus 43 is 1980. And so that means that if this is the correct choice, then the answer would be 1981, which it turns out to be correct. Now, if you want to give a bit of a proof, right? So I'm just going to outline a proof. basically I want to say that if we pick any of the numbers from 2 to 44, then I am already going to lose at least 43 numbers. Okay, and as an example, because I'm running out of space and also because not all of you are interested in the proof, you are more eager for the next few questions, right? So for example, if I pick 44, it means that I can pair all these numbers up, and in each pair, so whatever 43 times 44 is, and then 45 and 44 times 45. So if I pick 44, then these 44 numbers, sorry, these 44 pairs of numbers, I'm already going to at least lose one from each pair. Okay, so that's to show that we can't actually do better. Yeah, so this is just a little bit of a teaser because if you're watching this, it probably means that you at least have been watching some of my videos, you have been preparing for the SMO, so you would have a higher than average chance of encountering a round 2, right? And qualifying for round 2 either this year or next year. This is the sort of argument that you would need to be able to make for the round 2 questions. But for round 1, you can rely on the intuition, just the top half is good enough. So question 17. I think we'll just do up to 18 and then we'll take our second break. Okay, so question 17. Difference between the LCM and HCF is 627. We're back to the theme again of you can list, right? You can list because it means that the LCM is going to be the HCF plus 627. The HCF is, among other things, a factor of 18. And the LCM is a multiple of 18. Meaning that, well, there are not many factors of 18. And I need to make sure that when I add on 627 to this, I get a multiple of 18. Now 627 divided by 18 is 44 remainder 15. And so therefore, if you want to get this pushed up to a multiple of 18, you must have the HCF is 3. And the LCM is 630. Now, if you want to find the value of n, the HCF of n and 18 is 3, and the LCM of n and 18 is 630. The cool thing about HCF and LCM of two numbers is that the product of the two numbers is just going to be the HCF times the LCM. So you would be able to immediately extract out the value of n. Reason, in case you are seeing this for the first time, is that the HCF will take the smaller powers in the prime factorization from each number. Each prime number, it takes the smaller power, and the LCM takes the larger one. So if you combine the HCF and LCM, you get the smaller and the larger, which is just the two numbers themselves. I keep going back to this listing idea because even for round 2, listing is fine. As long as you explain why your list is exhaustive. So if, for example, you reason out that based on blah blah blah, we only might have solutions from 1 to 20, and then you list out 1 to 20. That's okay. But if you just listed out 1 to 20 and you said there should be nothing else later, then that's not okay. Right? So listing is always fine as long as you justify things properly. And finally, you get this weird thing here. Right? And it's weird because suddenly towards the end, you see mysterious appearances of easy questions again. That's why I keep saying the questions are not in order of difficulty. Right? So sum of interior angles except one. We know that the angle sum, if we say they're n sides, angle sum is n minus 2 times 180 degrees. And you took away one angle that is less than 180 degrees, meaning that your 2023 is going to be somewhere in this range. So this is straightforward enough. Divide by 180, 11 remainder 43. And so therefore, n is going to just be equal to 14. Okay, so we have 7 questions left. They're not all difficult, but there are a couple of them that are interesting enough to merit us taking another quick 5-minute break, and then we will wrap up with the rest of the problems quite soon. I don't have time to monitor the chat, right? But just please be nice. There are some of you here who are taking the SMO for the first time, so please don't be discouraged. If you see anyone saying that, oh, I got full marks or almost full marks, they've probably been doing Olympiads for a long time. If you're new, don't be discouraged. Things will make more sense the more you work on these questions and the more you see some of these ideas. before we continue, right, I just want you to notice something. The clock, right? It is 5:25, right? So we started at 4 o'clock. I spent 5 minutes doing an intro briefing, and then I spent 5 minutes on 2 separate breaks. So essentially, we have spent 1 hour 10 minutes. Now, that's not to say that, oh no, oh my gosh, you mean I am that stupid that I couldn't even do the questions in 2.5 hours? No, that's not my point, right? My point is just that for the SMO Junior, the steps themselves are not that long. You might take a while to figure it out. That's where the time goes, right? But once you have figured it out, the solution itself, the length of the solutions tends to be quite short. That's not true for the SMO Senior, and it's definitely not true for the SMO Open. So if you have done the Senior or you are doing the Open tomorrow, my suggestion is that for most of those, you are going to actually have a more serious time crunch. So pick and choose the questions a bit more. For the Junior, at least once you've figured out the method, the steps are not going to be unbelievably long. Whereas for Senior and Open, sometimes it takes quite a while. Yeah, another thing is just, I called this paper weird because I can't really call it difficult or easy. It's just weird because it looked very weird. That was my first reaction when I saw the paper. I just looked at it and thought, this is really strange. But it's only strange because the SMO has skewed towards being quite, if I may say, quite predictable for the last few years, where you have, let's say, that same weighing balance question at question 3. You have the same order the powers or fractions at question 1. You have got the HCF and LCM at question 6. And then you have got in the middle, you have got one, let's say, tangent circles touching each other. In the middle, you have one of this question where you're supposed to use the conjugate to rationalize the fraction. Like, a lot of them have repeated a lot. That also pushes up the cutoff naturally, but it has repeated a lot. That's not really the spirit of Olympiads, right? The spirit of Olympiads is supposed to be questions that look different every time, for the most part. So I do, in a sense, appreciate, right? I want to say that for whoever has come up with this set of questions, it's at least a pretty different looking set of problems. And different looking automatically means difficult under time constraints because you get thrown off from your expectations. But it's actually not a bad Olympiad paper. It's just that it is weird compared to what we have seen in the last few years. Question 19 is not weird. It's something that has shown up many times. And the idea is that you are supposed to just clear this nested set. You just need to clear this nested set by it being, let's say, square root m minus square root n. And then square both sides of this. Okay, so m plus n is going to be the nice part. 2 square root mn is the not nice part. So 19 corresponds to this, and 8 root 3 corresponds to this. Okay, so if we square this, mn is going to be equal to 48. This is, by the way, something that we are not always able to do. But if this simplification doesn't exist, it can be shown that it cannot be a root of a quadratic. Meaning that if it doesn't just collapse into something plus square root something, something minus square root something, then this would not be a root of a quadratic equation where a and b are nice. So you can expect it must be like this. Okay, so m equals to 16, n equals to 3 by inspection is going to be your solution. And so therefore, square root 16 minus square root 3, or 4 minus square root 3, is actually what is inside here. Now, 4 minus square root 3 is a root of this equation. There are two different ways you can go about it. One way to go about it is just to substitute it in. When the obvious method works, then nothing wrong with doing the obvious method. Just put it in, expand this carefully. Actually, 4 minus root 3 squared, we literally know that it's 19 minus 8 root 3. So I can just write that down. And so since a and b are rational, it means that this portion and this portion both must be 0 separately. So this is one way to do it. The other way to do it is to actually start from x equals to 4 minus root 3 and try to establish a quadratic identity about x by getting rid of the square root as follows. Shift the 4 over and then square it. So this would also give you that a and b are 8 and 13. Okay. Now, question 20. Now, there's such a thing as a question being too hard for the SMO Junior. And this question, if it were just a full-fledged, like, find all solutions, is definitely too hard for SMO Junior, even a SMO Junior round 2. Now, if we go with the potential idea, you have seen difference of squares many times, right? Even in my crash course, I mentioned it. If you go with the difference of squares, which is that the fourth power is also a square, you don't really get much out of it. Because y may be a prime number, it may not be a prime number. So you cannot say that one of them is y squared, one of them is y. It could be that it's just two numbers multiplying to y cubed. So this doesn't really seem to go very well. Now, those of you who have seen some modular arithmetic ideas, you may consider, okay, is there some sort of mod this or mod that that can do a filtering? And to be honest, I don't really see a simple one. And the reason why there isn't really anything that is very simple is that unfortunately, if the answer is very small, no filtering is going to help, because the purpose of filtering is to start to shrink it to something very small. Right? I did mention in my crash course video again about how you have the one where the answer is 99. So it is 99. That's the biggest two-digit number because it just is. Now, since my cubes and fourth powers are very far apart, but there are quite a lot of squares at least, so I can just sort of list out the first few fourth powers and cubes. So let's list a few of these. I'm just listing up to 10, right? You don't have to list it all at one go, but I'm just listing all the way to 10 just in case. Right, and I'll just list the first bunch of cubes as well. Now I'm going to be looking just for when can this potentially be a square. And for the first few, there are not that many candidates to check, right? So 1 can only be -1, 16 can only be -1 or -8, 81, you have got 4 possibilities. So yeah, there isn't really that much to check. And they're all small enough that it is quite obvious they are not square numbers. Now for square numbers also, a quick filtering can also be the last digit. Right? So we know that the last digit of your square numbers cannot, let's say, be a 2 or a 3 or a 7 or an 8. So a lot of these can be quite easily filtered out. Yeah, so it's a little bit so-called unfortunate that this actually works and is, it's the best I've got, right? If you have something better, let me know. But it turns out that you don't have to go that far, because actually this works. Somewhat sooner than we might expect. So for the rest of them, it's just a manual check that 256 and 625, you subtract off, you don't get a square, and then this one works. Yeah, it's just like that. I don't really have anything else to add, unless someone has a systematic way to get this solution, then feel free to share. So of course, just for the record, answer is n equals to 6. Okay, 21. We have got a right-angled trapezium. We have got a length 6, a length 10, and a length 17, and another right angle. So this becomes a sequel to our lots of right-angled triangles means that you can get Pythagoras and you can get similar triangles. Right? Because if, let's say, we again just start labeling an angle here, this is the complementary angle, then this would also be a complementary angle. So I'll just make the right angle a bit straighter. And this is complementary to that again. So you have got two similar triangles once more. And so AE and ED, we know that they add up to 17, but also now they belong in similar triangles. So that means that we have got two unknowns and two relationships. First of all, of course, they add up to 17. And second of all, 6 over x is equal to y over 10. So xy is equal to 60. Now, it's not very difficult to see. Now, x plus y is 17 and xy equals to 60. Whenever you have got a sum and product, we know that there will always just be two solutions. And the two solutions are just the reverses of each other. So you can solve it so-called properly, or you can just look around. For these kinds of geometry questions, it's not asking you to find x to the 4 plus y to the 4. It probably is going to be nice. What you're going to find is that xy is just 12 and 5, or vice versa. And the or vice versa is important, because when it says largest possible value of k, you realize that, actually, there is no good reason why x is 12 and y is 5 is wrong. Notwithstanding the diagram is not to scale, right? So we were talking about not to scale diagrams earlier. It is still true that if we say that this is a diagram, then E is between A and D. That we know. Now, whether AE is longer than ED, that's not part of scale. E being on AD is part of scale. Right, so therefore, we have two options. Both of these we can find using Pythagoras. So it's either that if it's 12 and 5, X is 12 means it will be square root 6 squared plus 12 squared. X is 5, square root 6 squared plus 5 squared. CE, either square root 10 squared plus 5 squared or 10 squared plus 12 squared. Now finally, the right angle also just does one more simple thing, which is that it makes the area of the triangle very nice. So the first one is 6 root 5 and then 5 root 5. So this is 75. The second case, this is just square root 61 and 2 square root 61. So it's just equal to 61. And obviously we just take the bigger one. Then we get to a very weird thing, right, which is question 22 and 23, which are basically back to primary school questions again, just phrased in a slightly unusual way. We're just given a clock question where 3 o'clock and something, you get a 175-degree angle between the hour and minute hand. I just want to say something, which is that if you're doing Olympiads for the first time at the secondary level, once in a while you're going to get your leg pulled a bit by some of these so-called primary school questions because you didn't actually learn the Olympiad techniques in primary school, and then after that you never really need 90% of them. But when they just pop up, if you find it difficult, don't feel embarrassed. It's okay. Just learn it for the first time in secondary school. It's okay. Right? For me, I think that we sometimes underestimate how hard it is to think of some ideas on your own because we were taught it when we were so young. So anyway, for this, how I like to approach this is that you start off from just 3 o'clock. And you just say that the hour hand is 90 degrees behind. Sorry, the minute hand is 90 degrees behind. And then the rate of the minute hand is 6 degrees per minute. The hour hand, the rate is 0.5 degrees per minute. And so the gain is 5.5 degrees per minute. So it went from 90 degrees behind to 175 degrees ahead, right? Meaning that it would look something like this. Or it could also be the other way. So it could be, at the end, it is 175 degrees ahead, or it is 185 degrees ahead. Now, both of these are possible, but y is an integer likely means that one of these can be ruled out. Okay, so from 90 degrees behind to this, you just add on. So 265 and then 275 degrees, and then the time taken, you divide by 5.5. So this one would give you 50, this one would not give you a nice number, it gives you 48 and 2 over 11. So that tells you that y is indeed 50. Question 23, this is a bit of a throwback also, because haven't seen these sorts of questions in the SMO for a while. It used to be actually in the early 2000s and 1990s that there were some of these sorts of questions, and then it just sort of disappeared. So actually there is not really any information in the question apart from 20 minutes and 2 km. The rest is just describing what is happening, right? So C is just somewhere, right? We know nothing about C, so the location of C is actually irrelevant. So all you need to know is that the man dropped the water bottle at A. The water bottle just continued floating downstream from west to east. So it means that this is your downstream current. And so he swam upstream, realized it, and then U-turned back. When you see this kind of question, there is probably some way to do it with a mountain of algebra, but you should at least try to consider the simple possibility that maybe there's just some trick here. Now I'm going to just note what happened for the first 20 minutes. Right now, the man, how much did he cover? Now the man basically went upstream. I'll call it 20 man-minutes. But this is offset by 20 current minutes. Meanwhile, the bottle presumably does not know how to row itself, so the bottle is just going to be down by 20 current minutes. Current minutes being, and man minutes being a unit of distance in this case. That I write like this without any variables in order to help you see that this cancels out, and basically it means that the distance is just going to be, well, as good as 20 man minutes. It's quite obvious in retrospect, right? Because if the current helps both of them. If the current blocks, it blocks both of them, so it cancels off. Now, after you U-turn, the same logic, right? The catching speed is also going to just be the man speed. It doesn't matter what it is, it doesn't matter what's the current speed, because the current speed will cancel out. And so it implies that 20 minutes is the time taken to catch back up. Yeah, so it's 20 minutes in both directions. And so that means that the water bottle took 40 minutes to cover 2 kilometers. Okay, so 3 km per hour is going to be your answer. Now, yes, I am aware that if you do some physics Olympiads, then you may be able to think of this in terms of different reference frames, right? You can look at the reference frame of the river, the reference frame of the man, or the reference frame of the water bottle. I'm trying not to go into that, but it can certainly help quite a lot. Okay, so finally, we have got a couple of questions that are, well, back to not being primary school questions. Now, question 24, xy plus x plus y, yz plus y plus z, zw plus z plus w. This is actually just sort of symmetric. And one of the things that we like to do for this is to so-called complete the factorization. Now, we want to factorize so that we can use the positive integer condition. But xy plus x plus y in itself is not yet ready to be factorized. The front part, you have an x, but the back part, yeah, there's no x. So how we do it is that we can append a 1 in order to get the factorization ready. And that's basically what we are going to do for all of them. Factorization is so that we can also prime factorize the constant. So of course I shall proceed to do that. Okay, they are all a bunch of 3, 5s and 7s. Okay, the product x, y, z, w. That actually has nothing to do with this, right? That's just sort of a final check your answer kind of tool. It basically means that at the end, you can check just whether it works or not. Now you can either do a direct guess and check, or you can just sort of throw in the prime factors one at a time, which is something that I like to do. Right, so I will look at each of them one at a time and try to figure out, well, what happened here. So first I will look at the tree. Now the tree appears a total of 3 times, and in order to make it appear 3 times, there will be one tree that's repeated and one tree that is not. So either the tree appears in the y and the w plus 1, or the tree appears in x plus 1 or z plus 1. So either it's going to be these two have a tree, or these two have a tree. The others don't have any much ambiguity though. If you are trying to split up the 5s, you see that the middle one has no 5. So all the 5 squared must have come from w plus 1. And at the top, the 5 must have come from x plus 1. And then for the 7s, 7 squared doesn't fit into y plus 1 or z plus 1. So it must be 1 each. Meaning that you have just got 2 possibilities. It's either that you use the first row, the 3 times 5, just 7, 3 times 7, and then 25, or you use the second row, so 5, 21, 7, and 75. Now it's pretty easy to see that the second one doesn't work, because this would mean that W is 74, and 74 should have a factor of 37, which is nowhere to be seen here. So this is out, and so it means that this is indeed correct. And we can check it, right? X is 14, Y is 6, Z is 20, and W is 24. Last question. Now, before we go through the last question, which is obviously not the easiest question, right? Even though I can't give you any specific cutoff scores, I have no idea. What I can say is that the cutoffs don't depend on the hardest questions. If in your entire school, only 2 people solve that question is essentially irrelevant. Right, so the cutoffs only are dependent mainly on the middle difficulty questions. The easy questions everyone would solve, the hardest questions hardly anyone would solve. And so if a question is just solved by 20 people or 15 people in the whole of Singapore, it basically doesn't affect the cutoff at all. Okay, so please don't get too frightened by, let's say, someone or 2 or 10 people that you know scored very well. Most likely, that's not going to be indicative of the cutoff score. Right, that's all I can say. I have difficulty putting a number on it because, you know, when I'm explaining it out loud, the questions look a bit easier, don't they? And that's usually what happens. Like, after explaining it, it feels a lot easier than before I started explaining it, and maybe you think that as well. So I don't know, but don't be too alarmed by what a handful of people score. Okay, so question 25. You realize that for question 25, more or less everything is fixed in place in terms of the drawing. Alright, this is divided into 4 equal parts, and this is divided into 2. So when it says least possible value of x plus y plus z plus u, there is a small chance that it's up to you to arrange the triangle to control this ratio, but it's more likely that it's just asking you to reduce the ratio into so-called lowest terms, and that's all. You just want to find what's that ratio. Now, the first thing that I notice is that the x, y, z, u will correspond to the ratio of the left side triangles. So, just for convenience, I can assume that these areas are literally x, y, z, and u. Right? In other words, I just assume that the height is 2. I mean, I can. The scale doesn't affect the ratio, so let's assume that. Now, I want to find the areas of those on the right side, and I want to find them in 2 different ways. I want to find them in 2 different ways so that I can actually get some sort of an equation relating x, y, z, and u. So first of all, I am going to just note that based on this being x, y, z, and u, the total area is going to be twice of that because the other side is the same. And so that means that ACE, AED, ADF, and AFB are all going to be just 1/4 of the total area, which is half x plus y plus z plus u. So that's the first thing that I can say. Now, the second thing that I can say is that I can also use the fact that these are equal, AM equals MB. So for example, to find this top triangle, okay, let's just call these points PQR. Now, the area of CPE is 1/4 of CPB, and CPB is equal to the area of CPA, which is x. So I want to basically do the same for the other parts. So this takes a little of time, right? But it's the last question. I think we can accept that the last question takes a little bit of time. It's not very hard, but it just takes a little bit of time. Right, so same thing. CDQ is half of CQB. CQB is equal to CQA. And so that is half x plus y. So I need to subtract off the 1/4 x, so I get 1/4 x plus 1/2 y. Now just repeat this couple more times. So CRF is going to be 3/4 of CRB, which is equal to 3/4 of CRA. So it's 3/4 of XYZ minus of this stuff. And then lastly, this whole thing is just x plus y plus z plus u. Subtract this all off and you get 1/4 x plus 1/4 y plus 1/4 z plus u. Okay, so we have now got everything in terms of x, y, z and u without even using this equation over there. And that's good because it means that now if I add up each of this, 5/4x equals to the next one, 1/4 x plus 3/2 y equals to 1/4 x plus 1/4 y plus 7/4 z is equal to 1/4 x plus 1/4 y plus 1/4 z plus 2u. Obviously, this is enough for you to get the ratios. It's a bit boring, so I'm just going to give you the ratio straight away. 3:2, 7:5, and 4:3. Right? It's not that bad, right? Because the 1/4s keep cancelling out, so you don't actually have a complicated mess. It's just a lot of writing. Okay, so finally, your overall ratio, if you put it together, is 42 to 28 to 20 to 15, and the sum is 105. And would you look at that? We are done in 2 hours this time. Now I want to, just before we end off, mention a couple of things. First of all, if you have any quick questions, I think we can just leave this open for like 10 more minutes in case you have any questions that you want to ask, and we can address a few of them. Secondly, if you're taking the SMO open tomorrow, feel free to just leave. It's okay. Just leave, and all the best. And yeah, do start looking at the round 2 questions if you haven't looked at them, because it definitely takes a while. And if I want to be just very honest, by the time you have found out that you qualified for round 2, it's too late to prepare for round 2. So the results will come out in a couple of weeks normally, but you would like to be ready even before that by having looked at some of the questions. Okay, so yes, that is basically all that we have for this SMO paper. Stick around if you have any questions to ask. If not, then I will end the stream in about 5 minutes or so. Yeah, so of course, on average, the cutoff for round 2 was about 14. Last year, I think it was 16. Generally speaking, 14 or 15 is usually, like 13, 14 or 15 is usually the cutoff. I don't think that let's say one question on logarithms is going to substantially change what is going to happen for the cutoff, because there will always be 1 or 2 questions that are impossible to solve for almost everyone. Okay, so cutoffs will be, I said, I don't foresee it changing that much from like the 14, 15-ish kind of range, unless they do consider having a lot more or a lot fewer qualifiers for round 2. Senior review, yeah, so same time, senior for tomorrow 4 p.m. and then open will be in 2 days time at 4, right? Last year I tried to double stack the senior and open session, and then I realized that both me and everyone sort of ran out of brain power, because senior and open, I stacked it on the same day as the actual SMO open, so no one could stay awake. So I split it up for over 3 days for that reason. For open, I guess, yeah, assuming that if you are here, most of you have taken the SMO Junior, right? Don't worry too much about the algebra specific topics. Like let's say if you have some complex numbers, or if you have some trigonometry that you have not learned, don't worry about it. So just for open, just look for the easy questions. In practice, for 95% of you, the easier open round questions is going to occupy most of your time already. Yeah, and then I guess, yeah, finally, if anyone is watching this back sometime not live and you have any questions, then just leave it in the comments section below. I usually will take a look at the comment section for the soon after the review. I won't look at it continuously, but I will try to respond. Yeah, I haven't finished doing the SMO senior questions, you see. So I mean, I only got access to the questions at like sometime about 1 o'clock or 1:30. So as you would imagine, yeah, I was only able to prepare the junior questions, and then like for senior, I just ran out of time at like question 15. So I'm going to look at the rest of them right after this actually. Yeah, questions. We didn't get the questions in advance. So the questions is just from anyone that took part. You can bring back the question paper. So I just go around begging someone to give me a copy of the questions so that I'm able to look at them. Right. So I don't get to see it before this morning. Definitely, I don't get to see it before any of you guys. I see it after everyone has already taken it. Yeah, so I see a lot of questions revolving around the cutoffs and difficulty. Again, all I can say is I don't know. Unless something drastically changes, I don't foresee it changing that much from like the 14, 15 kind of range. But if let's say suddenly they admit more students this year into round 2, it may reduce the cutoff a bit. I don't know whether the reduction from 190 students to 107 students into round 2 for last year is because of COVID, or it's just a decision for how to run the SMO Junior henceforth, right? So if it's going to go back up, the cutoff will drop. If it's going to stay the same, then the cutoff probably is not going to drop that much. So this is more for the SMS. I am not too sure. Difficulty wise, I feel that overall it's actually quite similar. It's just stranger looking. It's a bit weird, but overall difficulty is not hugely different. It just looks different. That's the main thing. Okay, so I think I will end the stream now. So thanks everyone for being here, and all the best if you're taking open, and see some of you tomorrow and on Thursday for the other 2 sessions as well. So have a good rest, relax, don't be too unhappy about SMO. It's just going to be one time. You're taking junior, you still have many chances to go. Okay, so thanks everyone, and goodbye for now.